Hey there, my name's Erica Gilbert. I'm a flight instructor in the central Kentucky area, and today we are looking at the weather from the perspective of a general aviation pilot. Many of us might be VFR only, others might have their instrument rating, so they've got more capabilities, and the vast majority of us are not flying airplanes certified for flight into known icing. In our light piston aircraft, we're going low and slow. We don't have the ability to get over most of the weather. Some of us can't go through it, and our ground speeds often don't let us go around it. So today we're looking at areas of VFR weather and areas of IFR weather, and the hazards that exist within both of those areas. Welcome to AeroSafe. Okay, doing things a little different. I'm recording Saturday evening at 8:15 Eastern, or 1:15. Okay, we're doing things a little bit differently this week. I'm currently recording in the evening on Saturday the 8th at 8:15 Eastern, or that'd be 1:15 in the morning Zulu time on Sunday. We're going to start, as we always do, looking at the surface analysis chart. And we're going to be using the AeroSafe Weather Brief checklist to guide us through our weather brief today, which you can access at gilbertaviation.com/aerosafe. Pulling up the surface analysis chart, we are going to use this to look at the areas of pressure systems and frontal systems. This tells us a lot about what's going on in the atmosphere and will give us an indication of the kind of weather we can expect and a reason for the weather that we see across the country today. I normally like to flow east to west when we look at these. So up in the far northeast, we've got a nice high pressure system. So that high pressure system is going to bring some pretty good weather up there. Relatively low surface visibility, but high pressure is stable air. It's resistant to vertical motion, so it's going to be typically pretty good weather. Now, we've had this kind of interesting frontal system coming through the east in the past couple of days. We've got a little bit of a warm to stationary front, tiny trough over South Carolina, and then a warm front from South Carolina up into Indiana. Now, at the tip of that warm front is a low pressure system, and then a cold front extends from there, from northern Kentucky, all the way down through Texas and then back up into nearly into Colorado there. A couple of troughs extending north up from that low pressure system. So we've got this low pressure system over Indiana. Here is a check ride question. How does air move around a low pressure system? When we think about how air moves around a pressure system, you want to think about it in all three axes. So vertically and out, and then also out the other way. So low pressure, air moves around a low pressure system. It goes up vertically through the atmosphere, it comes in towards the center, and then it also rotates counterclockwise. So if we look at this low pressure system, and we think about the air moving counterclockwise around it, what is likely going to happen? I look at this. I see the cold front and the warm front. I know that we've got that counterclockwise motion from the low pressure system, and I'm thinking there's a really good chance we might see an occluded front develop if these fronts remain strong enough to be depicted. Okay, so we have that cold front, a couple of staggered cold fronts moving down into the southeast, and then behind that we've got this high pressure over the Dakotas, and on the back end of the cold front would be what we consider a continental polar air mass. So air comes from over the land. Continental, polar means that it's cold. So the characteristics then of this air mass are that it is dry and it is cold. And we see that there's not a whole lot of visible moisture on the satellite part, on the radar part of this map. Okay, as we often see over the Rockies, there's a bunch of different pressure systems, high pressure, low pressure, some stationary fronts, some troughs. There's a whole bunch going on in that area. And then we see in northern Utah a little bit of wintry precipitation. Montana, Idaho, Oregon, some high pressure, and then up north of that, some low pressure. What's interesting to me is that we see the pressure in millibars. What is the pressure in millibars over this low pressure system? Well, it says it there. It's 1,025 millibars of pressure. Okay, let's come back to the east. Look at this high pressure system over the Atlantic Ocean. It is the same pressure, 1025. I point that out to show you that these pressure systems are relative. So if you compare that high pressure to the low pressure here, that's a difference. But this low pressure, which is 1025 millibars, is comparatively low when you look at the high pressure systems over Oregon. So it's all relative, and even lower if you look at the high pressure coming in from the Pacific. Now this high pressure over here off the coast, the western coast of the US, makes me really excited for you guys over there in California, Washington, Oregon, because I know that you guys have had a little bit of an atmospheric river lately. So for those of you who are hoping for good weather to fly, you should have some really nice weather coming in. Okay, here's another check ride question. What is this yellow line with half circles on it? If you have watched my videos before, then you might be familiar with this. But this depiction shows the dry line. The dry line is very similar to a front in that it depicts the boundary between two air masses, but the air masses are not a difference of temperature. It's more a difference of dew point. So the dry line depicts a very strong boundary between the dry air from over the desert and the moist air from over the Gulf. Now what happens when these two pieces, these air parcels mix, can be some pretty bad weather. And that's really why we have a lot of tornadoes in that area. So that's the surface analysis. So now we've looked at the surface analysis. We'll look at the prog charts at the end. We're going to look at the airmets, sigmets, and pyreps now. And we will do that using the interactive map on 1-800-weatherbrief.com. And we are going to turn on, we'll start with the sigmets, okay? We have a couple sigmets in the contiguous US. This green one first is a sigmet for high severe turbulence, occasional severe turbulence between flight level 24,000 and 34,000. And fortunately, when it gets to the level of sigmet, it tells us why, due to wind shear associated with the jet stream, reported by aircraft. I don't look at these weather advisories all the time. I do look at them fairly often. But typically, when I have seen a sigmet for turbulence, it is because of multiple reports by aircraft, by pyreps. And so we talk on this channel about the importance of pyreps and giving pyreps and looking at them. You know, these pilot reports are given by pilots, and it's the only way to really know exactly what's going on. And this is one of the benefits of giving pyreps regularly, is that now, if we were planning to fly in this area at those flight levels, we would know maybe we don't really want to do that. Maybe we'll go around it. Maybe we'll try to get above it or try to be under it if possible. So while this is high-level turbulence, that does give us an idea of kind of what's going on in the atmosphere. And we see, again, it's associated with the jet stream. I'm going to turn on the radar as well here. Yeah, and there's some yucky stuff up there, which again, if we look at the surface analysis, yeah, that low pressure system and all these fronts mixing together. All right, additionally, we have this gray with dashed outline. That's going to be a convective outlook, meaning that the ingredients exist for a thunderstorm to form within that area. So here's another check ride question. What are the conditions that need to be present for a thunderstorm to form? Now, I've talked about this on previous videos, and those three conditions are sufficient moisture, right? That just makes sense. A thunderstorm won't form if there isn't enough moisture in the air. Lifting action. In this case, the lifting action could be that low pressure, which is vertical development, right? And an unstable lapse rate, meaning that the temperature doesn't really change predictably as that parcel of air moves up. So we have the dashed area is the convective outlook, and then the white areas are the actual convective segments. It's good to look at the convective segments because they tell you the tops of those clouds, the cumulonimbus, and also the speed with which they're moving. So here, area of embedded thunderstorms moving from the southwest at 60 knots. That's really fast. Tops to flight level 290. Then over in my part of the world, we've got some convective segments as well. Not as high and not as fast. Okay, so those are the segments. So it's not just enough when we look at these things to know what they mean. We've got to take it to the higher level and know how to make a decision based off of it. So for us in our light piston aircraft, first of all, we've got a lot of flight categories here that would be hard for a VFR pilot to fly in. So we see VFR with some ceilings in the area, marginal VFR, IFR, and low IFR. So if you weren't IFR capable and equipped, current and proficient, you wouldn't want to be in the area. Add to that the convective segments and the outlook, you'd probably want to stay even farther away from the area. So that would kind of be a no-go area here. We'll turn off the segments and turn on the airmets, starting with the tangos. Airmet tangos are issued for a couple of things. Primarily, we think of airmet tangos as being issued for turbulence, but they can also be issued for low-level wind shear and sustained surface winds greater than 30 knots. And we've got all of those on the map today. We've got an airmet for high-level turbulence from 18 to 34,000 feet, and that is confirmed by the PIREPs. When we turn those on, we'll see that. We've got low-level turbulence as well in these yellow shaded areas. Surface to 8,000, and the northerly one is 6,000 to 18,000. The orange areas are depicting low-level wind shear, which is an airspeed, they're saying due to an airspeed loss or gain of 20 knots or more below 2,000 feet. Another check ride question, what is wind shear? Wind shear is a dramatic change of wind velocity or direction over a small given area. Typically, we think of that as vertically. So as we move vertically through the atmosphere, there's a shift in wind velocity, so the speed of the wind or direction of the wind. Now that in and of itself isn't necessarily bad, but when it is low level wind shear, that's when we might experience some hazardous conditions and risk. Since we're already pretty slow when we're close to the ground, whether we're preparing to land or taking off, a loss of 20 knots when we're climbing out or on final approach could put us below stall speed. So low-level wind shear does have the potential to be very dangerous, especially when it's associated with convective activity like this is here. Off the coast of North Carolina, we see sustained surface winds greater than 30 knots, but I would think most people wouldn't be flying out there. This low-level wind shear would be an absolute no-go for me in a light piston. That is, all those things are stacking up to be no bueno over there. Okay, we also have some low-level turbulence over Wyoming and Colorado, both from the surface into the teens, not quite the flight levels, but pretty high up there. And I would think being on the downwind side from the Rockies, it's probably not great. And some high-level turbulence in Central California. Okay, airmet Sierras. Airmet Sierras are issued when you cannot see. So that's either IFR conditions or mountain obscuration, which is IFR conditions, but in those mountainous areas. It's no surprise that we see both of those where all that convective activity is taking place on the East Coast. Widespread IFR conditions, ceiling below 1,000, visibility below 3 statute miles due to mist and precipitation. Same thing with the mountain obscuration. So we've got quite a few areas of IFR there. Colorado has some mountain obscuration as well. And then the whole Northwest has mountain obscuration and some areas of IFR conditions. Okay, so we see a lot of IFR on the East Coast and up in the Northwest. Next thing we'll look at is the AirMet Zulus along with the freezing levels. AirMet Zulus are issued for freezing, but more specifically icing. So we can expect to encounter icing where there is visible moisture and the temperature is freezing or below, or honestly even near freezing. 3 to 5 degrees above freezing in Celsius, you might still accumulate some icing, depending on if those water droplets are super cooled or not. So icing conditions up in the far northwest, base at the surface, up to 14,000 feet. Okay, so the line that I've currently selected, the one that is thicker, is showing the freezing level at the surface. So the freezing level is the lowest altitude at which the temperature is freezing, or 0°C. And because that one's on the surface, the freezing level can't get any lower than that. So everything above that, the freezing level is at the surface, which means that any precipitation that you see could cause structural icing. Now, if we look at this chart from that perspective, any IFR conditions north of that will result in icing, which means that essentially, unless you are flying an airplane certified for flight into known icing, if you are north of this line and there's any moisture, that's a no-go. Again, if you are not flying an airplane certified for flight into known icing, anything north of this freezing level with moisture, that's a no-go. You can still continue looking at the weather briefing as a thought exercise, but that's half the country right there, over half the country, and a lot of the IFR conditions that we looked at. Now, as we move south, the freezing level goes up, but the question is it going up enough to fly at a safe altitude and still be out of icing conditions? If you're working on your instrument rating, you should be very familiar with personal minimums. For most people, their personal minimums consists of a ceiling and a crosswind component. Maybe fuel reserves as well. But personal minimums should be much more robust than that. For me, when I am flying in an airplane that is not certified for flight into known icing, one of the personal minimums I incorporate is this. I like to determine my cruise altitude first. I haven't even looked at the weather yet, so I'm looking at the map, figuring out a route, looking at my minimum altitudes for the route, determining what would be safe, what I would feel comfortable with. Obviously, if it's over mountainous terrain, I want to be above the MEA. I want to have lots of time, lots of space to figure out, hopefully time to glide to an airport. So I choose an altitude, a cruise altitude that I'm going to be comfortable with. Next, I'm going to look at the winds aloft and temperatures chart, and I want that cruise altitude to be at least 5 degrees Celsius. If we do it in that order, then you're not pigeonholing yourself into flying at an altitude with no room to move. So some people might say that they want to fly 2,000 feet below the freezing level. Well, what if the freezing level is 9,000 and the MEA is 7,000? Now that's pretty high MEA, right? Minimum en route altitude, and it's going to be that high if there is some mountainous terrain in the area. So now you are as low as you possibly can go. Freezing level is forecast to be 2,000 feet above you. It might not actually be 2,000 feet above you. Now you have no room, no room to go anywhere if things didn't actually turn out that way. So think about, when you're setting your personal minimums, what are you actually trying to mitigate? And how can you help prime yourself to make a good decision based on that risk that you're mitigating? Bottom line here is that based on the freezing levels and all the IFR, you'd have where the IFR conditions exist in the mountainous area over here, you'd have a hard time maintaining a safe cruise altitude that is out of icing conditions. So I'm going to go ahead and say that all of these areas that are IFR, I would not want to fly in unless, well, even, down by Nashville, I'm surprised. Oh, wait, is that where that convective sigma was? Yeah, okay. Yeah. So I'm going to kind of hold on to that. I think, based on what I'm seeing, pretty much anywhere that there's IFR conditions, if you're not in an airplane that can get high and go fast and get rid of ice, certified for flight into known icing, I wouldn't be flying in any of these IFR areas today. An exception might be along the coast. Yeah, it'd be along the coast. Mobile looks like a good place to do some IFR flying, maybe some instrument approaches. But it's interesting that it's like the only one that's marginal. Milton is IFR. It is raining really hard here right now. I am right in all of that. Okay, so we have looked at the SIGMETs, we've looked at the AirMets, and I've pretty much determined that aside from those handful of airports over the Gulf Coast, pretty much anywhere there's IFR conditions, I would not want to be flying today. For mountains, for freezing, for icing conditions, and for convective activity. That's a lot of holes in the cheese. Also, it's nighttime, so when I'm flying a light piston, there's 3 really huge risks or hazards that, we can encounter, and I will only do one of the 3. That is IMC, mountains, and night. We only get 1. I only allow room for 1. Okay. So, referring back to the weather brief checklist, we've looked at SIGMETs, AirMets. Let's look at PIREPs. Now, we know already there's going to be a lot of PIREPs for turbulence up in the northeast. Oh, yeah, here's a HUA. Severe turbulence and a Boeing 777. If he or she, if those pilots found that to be severe in a 777, Lord of mercy, I can't imagine. Okay? Also lots of PIREPs for icing. Turbulence, icing, low level wind shear plus or minus 15 knots in a CRJ 900 over Tri-Cities. And up in the northwest, we see some icing AirMets PIREPs as well, moderate rime, and some turbulence over in Colorado where we saw an Embraer 75, skies broken at 9,000, weather was 10 miles of visibility, turbulence light occasional, moderate chop, negative icing, plus or minus 10 knots on departure during climb. These PIREPs support the AirMets and SIGMETs that we saw, which is good. It's really good. Confirms all of our suspicions, which is that we shouldn't be flying in a lot of these areas. If you were actually going somewhere, when you pull up your weather brief and you choose the corridor, so the width of the briefing area that you want information on, you'll get all of the PIREPs specific to your route of flight. And that is whether you get your flight briefing through flight service or your electronic flight bag. You'll be able to look at those PIREPs one at a time and really see what's going on. One thing that I wish we could do that hopefully will become possible in the future is separating the PIREPs by altitude. It's nice to know about PIREPs above us just to get an idea of what's going on overall in the atmosphere, because we do need to be aware of vertically in the atmosphere what's going on. But being able to just glance at those by filtering them out, I think would be very useful, because if there's a whole lot, we might miss the ones that are most applicable to us at the altitudes that we're flying. Okay, we looked at freezing level. We'll look at cloud coverage next. I was just talking to someone today about one of my personal minimums. Again, talking about personal minimums, is that if I'm hand flying and instrument conditions, my limit on that is an hour and a half. flying by hand in instrument conditions can be really fatiguing, and you don't really realize how tiring it is. So this is one of the charts that I like to use. So we'll go to Decision Support Graphics. We're going to choose Graphical Forecast for Aviation. We'll just go 3 hours into the future, the whole US, and we want the cloud product. So this is a really great chart because it shows us, and it's modeled, it's based on modeled information. And so it's a forecast, it's not current, but it tells us where bottoms of clouds are expected and tops of clouds are expected. So it's a really useful tool to determine, are you going to be cruising below the clouds, above the clouds? And then you can use that and kind of measure it against your personal minimums to see, maybe I need to shorten the flight, stop 1 or 2 times more so I can take a break and rest, or maybe wait another day. So, for example, that convective activity that's over the east here is moving to the northeast, right? If we remember, it was coming from the southwest at 60 knots. So that convective activity, that lots of instability, lots of vertical development, we see that here with the tops of the clouds as high as they are. Up here in New York, Pennsylvania, flight level 270, flight level 310. Bases of the clouds are not super low, but that super high, super tall cloud is a really good indication that there's going to be convective activity there. On the flip side, looking down in central Tennessee, eastern Tennessee, that looks like a pretty decent day to do, or time frame to do some practice approaches or actual instrument approaches for currency, assuming that the convective activity has moved out and it's warm enough at the altitude where you want to fly to stay out of icing conditions. So that could be questionable in that area. Same thing up in the northwest. Pretty tall development of the clouds. Ceilings aren't super low though. So even though there was an IFR AirMet in the area, I suppose that they're expecting conditions to improve a little bit here. But there is still mountain obscuration. So the mountains will be covered by clouds. And there are still AirMet Zulus here. So if you were wanting to actually go fly somewhere, you'd want to zoom in on your part of the country. And then the data points are, the map is bigger, so the data points are a little bit more specific. And you can get a better idea of what's happening across your state, across your part of the country. It's a really great chart. If you were actually going on a flight, you of course would want to look at winds aloft because that's going to affect your ground speed, thereby affecting the distance you go in a certain amount of time and the amount of fuel you're going to burn to get there. So if you've got a tailwind, that's groovy, that's great, you'll get there faster. Headwind, the opposite, right? So you might need to determine, do I need to shorten this leg so that I can maintain my fuel reserves that I'm comfortable with? And then also on the winds aloft chart, you can see the temperature at the different altitudes. The aviation surface chart is one that I see come up often on check rides because there's a lot of symbology that an examiner can ask you about in one chart. So using this same decision support imagery page, I'm going to do the same forecast area. I'm going to go back to the whole US and I'm going to choose the surface product. This chart tells you everything that's happening on the surface, from wind to precipitation to winds. So like as in the surface wind, AirMet Tango, visibility, IFR AirMets. It tells you so much. This depiction here is really interesting, and I only know what it is because I looked at it recently on the NOAA, NOAA, National Oceanic and Atmospheric Administration's Imagery Legend, which is available in ForeFlight under Documents, Legends, NOAA Imagery Legend. This is moderate freezing rain or drizzle. So I mean, it just goes without saying, if there is frozen precipitation making it to the surface, you do not want to be flying. These 3 dashed lines indicate fog. So that's contributing to what we saw earlier on the METARs of, a couple of those, Mobile and that other airport had some fairly low ceilings. That's what's going on there. And then you can see the surface winds across the whole U.S. All right, if we kind of look at the wind up in Minnesota, coming down Missouri, Arkansas, Texas, it's kind of swooping a little bit in a, I would say, clockwise fashion. So what kind of weather system do you think would exist up in this area? If you remember, we already talked about it. But if you didn't know, and you were just having to use the information that you knew from the way air moves around pressure systems, what could be creating this clockwise motion up in the central part of the country? Let's pull it up and see the high pressure system up there. The more that you use these charts and look at all of them together, the better you will be at seeing these relationships and understanding, it's not just rote memorization that high pressure moves down, out, and clockwise. It actually is what happens. And we are shown that. We see it on the charts. It's very clear. And so if you build the really strong base of knowledge and theory and understanding, then you can take it to the level of application. And then you could even get to the point where you look at a surface analysis chart and you know what all the other charts are going to show you. And that's why I start with this surface analysis chart, because it gives us the big picture overview. And then we look more into the details with all of the other advisory products and charts that show us what the surface analysis already said. So that's the aviation surface forecast chart. If you're not familiar with it, I would really encourage you to look at it, especially if you're getting ready for a check ride. If you take an electronic flight bag into your check ride, anything in there the examiner has the privilege to ask you about. They can ask you to open the imagery tab and click any chart and ask you what it means. And if there are any that you're unfamiliar with, you don't want to find that out on your check ride. Now, if you are getting ready for a check ride or curious where your weather knowledge stands, there is a weather knowledge quiz you can take at gilbertaviation.com. It's a short, simple quiz just so you can see where you stand and know where some of your weak areas might be so that you can really focus your attention on what you need to study with the weather. So on this weather brief checklist, the second to last thing that I have is METARs and TAFs. I encourage us to look at this last because a METAR or a TAF could be somewhat misleading. They don't give you the whole picture. They don't tell you what's going on vertically in the atmosphere or what's coming down the way, really. These METARs and TAFs give you a very myopic view of the ceilings and visibilities and not much more within the next 24 hours. And as we know, as we've seen, there is a lot more information than just what's on the METAR. For example, if we zoom in here, along this line of convective activity in Lewisburg, Ellington, Tennessee, right now they're reporting wind 210 at 7, gusting to 12. That's reasonable. 9 miles of visibility. That's fine. Few clouds 3,300, scattered at 47. Overcast at 9,000. That is a flight category of VFR, right? We have more than 5 miles of visibility. We have more than a 3,000-foot ceiling. But overlay that with what we know already exists. My internet's going slow, but we know there is convective activity in that area. So even though this airport is reporting VFR, it's a very small picture. There we go. Finally popped up, right? This thing is in the heart of that convective segment. So I put METARs and TAFs near the end because they should just be confirming to you what you basically already know. Now, it wouldn't be a bad method to look at it first, get a snapshot, and then look at the whole thing. But if we put it last, then we're probably more likely to look at everything else first. All right, SIGMETs are coming back off. So if we look across the country, there are some nice areas of VFR weather. Up where we know that high pressure is over the Dakotas and Minnesota, really nice, really lovely. And I didn't really see any other issues there. I mean, Jamestown, North Dakota here. Light winds, 10 miles and clear. Really, really beautiful. And it's supposed to be pretty nice continuing forward. Tomorrow, near the end of the Taft period, the wind's going to get a little strong, so you'd have to be sure that that's within your personal minimums. But in terms of ceiling, still stays relatively high. Down in Texas, same thing. St. Angelo, ceiling will deteriorate. And it's a little windy down there. DFW, same thing. Ceiling's going to deteriorate. So Texas might not be so good tomorrow. The IFR areas north of like mid-latitudes, I'd stay away from those. Any visible moisture above that freezing level line depiction, you're going to get icing. So don't go up there. Let's look at the weather charts, the prog charts, and get a better idea of what you can expect in the next couple hours. Low pressure system still going to be hanging out over West Virginia, Kentucky in 12 hours, making a lot more nasty stuff. Northwest is going to look pretty similar as well. 24 hours from now, that's going to have moved out. That cold front has really come down and is still producing some precipitation and a little bit of ice. And there's also a chance of some ice in some of those northern parts of that precipitation. Northwest still kind of yucky. So let's also look at the low-level significant weather prog charts. Okay, so this is what we want to look at to determine flight category, turbulence, freezing levels. So that freezing level, again, is cuts right across the middle of the country. Any visible moisture north of that line tomorrow, Sunday, when you're watching this, that's going to be a no-go. We also have this blue cloud depicts marginal VFR. So within that, we can expect ceiling between 1,000 and 3,000 and visibility between 3 and 5 miles. So anything north of that purple zigzag line, which depicts the freezing at the surface, no-go. Below that, you got to be very mindful of where the freezing level is. And it looks like it's stacked pretty close because you want to be at a cruise altitude that is warm enough. The turbulence areas are high level, and then we see IFR along the coast. So marginal VFR in Texas, where I was looking at, it's VFR now, but it will deteriorate, and then right along the very coast, it'll be IFR. So there's a good chance that tomorrow in Mississippi, Alabama, Georgia, if it is within that marginal VFR bubble, assuming there's no other hazards, that could be a good day for some practice approaches. Gets pretty yucky as we go on into the day everywhere else too. So, I don't know. Okay, so again, big picture, areas of VFR weather are going to be in the central south part of the U.S. and then up in the central north part of the U.S. Now, Texas and surrounding areas, that's going to deteriorate. We're going to get ceilings that lower and along the coast all the way down into IFR category. Up in the central northern part of the country, that should remain pretty nice. Freezing level is pretty low across a lot of the country, so if you are intending to fly in visible moisture, be very, very mindful of where that freezing level is across your route of flight. And make sure that you are well above obstacles and terrain, and that altitude is at least 5°C, 5 degrees above freezing level. If I look at the week ahead for myself, it doesn't look too great for flying here in central Kentucky, which means that I'll be spending a lot of time on the ground with my students, progressing their ground knowledge, their systems knowledge, weather theory, regulation, airspace, all of that. And so, as I prepare for a week of probably being on the ground a lot, What do you do to stay proficient and current and moving forward in your flight training when there are long periods of time that you don't get to fly? What are you missing in terms of staying proficient and current in those bad weather times? Don't forget about that free weather knowledge quiz on gilbertaviation.com. And if you want a copy of that weather brief checklist that I used to guide me through this analysis today, you can get that at gilbertaviation.com/aerosafe. Thanks so much for tuning in, and we'll see you next time.